All right. So, hello and welcome everyone. I hope we are live now. So, welcome back to this particular channel of Pradhan Academy. And today we are going to discuss JEE Advance, right? So, as you all know, that JEE Advance is very nearby, and we have to get ready for the upcoming JEE Advance examinations, right? So, today I am back again with another very important topic on maths, and today our topic is going to be on 3D geometry, right? So, today we will be basically looking back at the concepts of 3D geometry, especially with mind that we have to prepare for JEE Advance, right? So, welcome back to this particular channel. If you're new to this particular channel, I would request all of you to please hit the subscribe button and click on the bell icon to never miss out any upcoming notification. Right. So we are conducting every day, every sessions. We are conducting sessions especially for JEE Mains, JEE Advanced, and the NEET examinations. Right. So students who find this particular content useful can definitely tune in to this particular channel. Right. So I welcome all of you to this particular lecture, and today we will be going to discuss about the JEE Advanced topics. And from today onwards, we are starting the series on JEE Advanced, and we are going to discuss the 3D geometry for today's session. Right. So I request all of you to please sit in this lecture and sit with your notebook and a pen, and let's get started. As I solve the questions, try to get the questions done by yourself as well. Right. This will actually help you to boost the confidence in your preparation. Right. And before you start with this particular topic, I would request all of you to please quickly go through your NCRT. Please quickly go through your NCRT, right? Because NCRT is must. Please quickly go through your NCRT, and after that go through your NCRT exemplar, right? And I know if you have done this particular thing for JEE Mains, it is very useful for all of you, right? So since you have done this particular part, then a quick revision is needed to get started on this particular chapter. And after that, please prepare some short notes, and then let's get started. So I hope you have prepared short notes till now, because maybe most probably while preparing for your JEE Mains, you must have prepared short notes and revised the short notes from that particular part, right? So with this, let's get started for today's topic. And today we have 3D geometry. Let's get started. So today our goal is to discuss the previous year questions of JEE Advanced. We're going to practice both MCQ and numerical type questions. We are also going to see the integer type question, and we are also going to predict what kind of paper can come up for your actual examination. So with this, let's get started. Here we have the very first question on our screen. Now I would request all of you to please pause this particular video at this moment and try to go through this question. Now whenever you look at the JEE Advanced questions, they are basically lengthier, right? If you look at the question, they have a lot of information embedded into those questions, right? So you have to read the question patiently. That's the first and foremost thing, right? So once you look at the question, once you tune into the question, it's very important to read and go through the question very nicely, because once you're not able to understand the question, then you're not able to do the question also properly, right? So it is very important to get an understanding of what the question is talking about, right? So as we look at this particular problem, it's a question of 3D geometry where it is clubbed with the concept of a straight line and a plane, right? So if you look at the problem over here, it is saying that there is a straight line which is drawn from a point. There is a straight line which is drawn from a point P. Now let us mark this point P as 1 comma 3 comma 2, right? So there is a straight line which is drawn from a point P, and it is parallel to another line which is given by the formula, or the equation of the line is given by x minus 2 by 1 is equals to y minus 4 by 2 is equals to z minus 6 by 1, right? So the most important factor while considering the parallel lines is the direction ratios, right? The direction ratios, they will be remaining the same. So based on this direction ratio, I can always write the equation of this particular line. Let us say this particular line as like capital L. So this equation of line will be simply equal to x minus 1 by 1 is equals to y minus 3 by 2 is equals to z minus 2 by 1, right? So since we have to maintain the same direction ratios, and the point of intersection, or the point through which the line is passing, is given as point number P, right? So this will basically make the general equation of the straight line L. Right. Now, once we have this equation straight line, we have to find that this straight line is intersecting the plane, is intersecting on a plane. Now, let us say this is a plane over here whose equation is given as x minus y plus 3z is equal to 6 at a point. Now, this particular line intersects the plane, this particular plane, and the plane is given as L1 at a point Q. And it is said that another straight line passing through Q, another straight line which is passing through Q, let us try to draw it over here. I know that it is getting clumsier, right? But manage it, right? I hope this is not making a difficult issue. I hope if you try to solve this question by your own and if you try to draw the diagram, you're going to get a better feel of it, right? Now, I won't recommend all of you to do these questions in this particular like a very clumsy manner, right? Because when you're doing for your rough work, it is very, very important to do your rough work properly and clearly. Because ultimately, if you're not able to do the rough work properly, then you're not able to get the correct answer properly, right? So that will create a lot of issue. That will definitely create a lot of issue. So please try to avoid that particular thing. Okay, so please don't make that mistake, right? You are doing all the rough work in a one particular small corner of the page and you're making things more and more complicated, right? So let's go to the question. So it is saying that a straight line passing through this point Q and is perpendicular to this particular plane. Okay, so here we have the line is perpendicular to this particular plane, right? So when a line is perpendicular to a particular plane, that means this line has the same direction ratio as its normal, right? So from the normal of the plane, the direction ratio of this line, let us call this line as some um, so I call this line as L. So let us call this line as some capital X. Okay. So this particular line passing this point Q as capital X and its direction ratios will be given by the direction ratio of the normal of the plane L1. Right. And it is said that it is perpendicular plane L1 and intersects another plane and it intersects another plane, right? And intersects another plane at point R, and that plane equation is given as 2x minus y plus z is equals to minus of 4, right? That's what the equation is given as, right? So simple question. So if you look at the problem over here, it is just a simple manipulations of the data, right? So you have to just solve the data step by step to get to the real answer, right? So once we have the point line L, let's solve for Q. So first and foremost idea is to solve for the point Q. So let us try to solve for point Q. Let us first of all assume any point on this particular line L as sum by a parameter lambda. So at any point on this line L can be given by parameter lambda as lambda plus 1, comma 2 lambda plus 3, comma lambda plus 2. I hope this is clear, right? Now, once we have to get this value of lambda, let us try to put that into the equation of the line, into the equation of the plane, which is given as x minus y plus 3 times of z is equals to 6. Now, if you put it over here, we are going to get the value of lambda, which will correspond to the point Q. So, the values is corresponding to this is basically lambda plus 1 minus 2 lambda minus 3 plus 3 lambda plus 6 is equal to 6. So 6 and 6 got cancelled over here and we are going to get that answer as, so this is going to be 2 lambda because lambda plus 3 lambda 4 lambda minus 2 lambda is going to be 2 lambda. 2 lambda minus 2 is, so here we have lambda is equal to 1. So therefore the point Q will correspond to the value of lambda, which is basically equals to 1. I hope this is clear, right? So therefore we have the point Q as 2 comma 5 comma 3. So we got the point Q as 2 comma 5 comma 3. Now if we need to write the equation of the line passing through this point Q and perpendicular to this plane L1, so that is like condition of here. So it is passing this point Q and is perpendicular to it, so we will have the same direction ratio as the normal of this particular plane. So the plane equation is given as x minus y plus 3z is equal to 6. So from here the direction ratio of the normal is basically 1 comma minus 1 comma 3, right? So therefore this particular line passing this point Q will also have the same direction ratio. So I can write the equation of the line x, right, is basically x minus 2 by 1 is equals to y minus 5. So because point Q is basically 2 comma 5 comma 3 and by minus 1 is equals to z minus 3 divided by 3, right? So this will basically be the equation of my line x, right? Now I have to solve for point Q, sorry, point R, right? I have to solve for point R. So let's do the same procedure. Let's equate this particular to some parameter mu, and then the point R, any general parametric point R will be given as mu plus 2 comma minus mu plus 5 comma 3 mu plus 3, right? So this will be the general point R. Now it is said that this particular point lies on this plane 2x minus y plus z is equal to minus of 4, right? As mentioned on the problem over here, and that will give you, so this is a plane L2 and that will give you point R. So let us solve for point R. We will get, so solving for point R, we will get, let's put it over here. So 2 mu plus 4, then plus of mu minus of 5, and then plus 3 mu plus 3 is equal to minus of 4. And solving for mu, we get the value of mu as, so we get the value of mu as minus of 1. So you can solve for this value of mu So this is going to be 6 mu, and this is going to be -1, and plus of 3 is going to be plus of 2, and if you take on the side, it's going to be minus of 6. So 6 mu is equal to minus of 6 is equal to, so therefore mu is equal to -1. So once we have mu is equal to -1, this point R will be given by 1, 6, 0. So we have the point P, Q, and R. Right. So now once we have solved for all the unknown points, let's try to go through these options. Okay. So the first option, it is saying that the length of the line segment PQ is √6. So let's check. So length of the line segment PQ, let us calculate the line segment PQ by the distance formula. So the distance formula, then it is basically square root of, so we have 1 square plus, so I'm not repeating the formula over here. I am assuming that you have already cleared JEE Mains, so you must know all this particular formula, right? So with this, so 1 square plus 2 square plus 1 square over here, and that will give you the distance as √6. That will give you the distance as √6. That is true, right? So therefore the first option, that is the length of the line segment PQ is √6. This is basically correct option. So the coordinate of point R is 1, 6, 0. So this is not correct. So this is wrong, right? Since it's a multiple type choice question, so therefore you have multiple options which will be correct, right? Now it's also asking for the center of the triangle PQR. So center of the triangle is given by x1 plus x2 plus x3 by 3. Similarly, y1 plus y2 plus y3 by 3. Now if you put this particular formula over here, and if you solve for these values of x1, x2, and x3, and y1, y2, and y3, correspondingly, you will get the center of the point of this particular triangle as 4 by 3, 14 by 3, 5 by 3. That's the correct answer, right? You can check for it. Okay, you can check for it. You will definitely get this particular solution. So that is very correct, right? And the last question is basically talking about the perimeter. So perimeter of the triangle PQR. So once one of the length PQ is basically √6. Similarly, if we try to calculate the length of the line, so similarly, we try to calculate the length of the line QR, we'll basically get QR as √11, right? And if we try to calculate the length of the line PR, it is basically √13, right? So therefore, the perimeter is √6 plus √11 plus √13. Therefore, this is not correct. This is not correct, right? This is not correct. So therefore, the only correct answer to this particular question is going to be option number A and C. Option number A and C. I hope you are also getting the same answer as me. I hope all of you are getting the same answer. Please let me know in the comments in the live chat. All right, and if you're watching the session after the live class is over, you can always comment out your doubts in the comment section after the live session is over. Okay, but I'm looking forward to your good feedbacks. Okay, I hope this session is helping you out, right? So I'm trying my best to provide you the best and fruitful material, and we are also trying to solve the JEE Advanced previous year question. And from these questions, we are trying to understand and trying to get a feel of how the questions are basically being asked in the JEE Advanced paper, right? So the best way to get a feel of how the questions are asked is basically to go through the previous year questions, right? I hope this particular part of the solution is clear to all of you, right? All right. So with this part, let's move to the next question. Let's jump into the next question. Okay. So the next question is another very interesting question. So the way of asking the question is very interesting. It says that R3 denotes the three-dimensional space, right? And we have 2 points P and Q, which are given out as follows. And let distance dist function x comma y denotes the distance between 2 points x and y, right? Now it is said that set S is a set of all the points x which is belonging to the three-dimensional space such that the distance of this point x comma p whole square of it minus distance of the point x comma q whole square of it is equals to 50. Similarly, T is a set of all the points for y for which the distance of this minus distance of this is equal to 50, right? So it is talking about a particular distance we have to evaluate from here, right? So let's try to understand how we proceed with this question and how we try to figure out that what is our given corresponding set. Now let us say I assume this point x as x comma y comma z. Okay, let us say. So in order to find the set S, I assume this any arbitrary point as x comma y comma z, and similarly for set t, let us also assume the arbitrary point as another x comma y comma z. But please don't get confused that this x comma z is corresponding to set S, and this x comma y comma z is corresponding to set t. Right now it is said the distance of the point x and p and distance of point x and q the square of the distance is differed by 50, right? So if I try to do that, so for the first part, will basically become x minus 1 square plus y minus 1 square plus z minus 1 square, right? I hope I'm doing correct. So this is point x and p. So okay, very sorry, this is basically going to 2 and this is going to be 3, right? It minus this particular distance square minus x minus x and q, x minus 4 whole square plus y minus 2 whole square plus z minus 7 whole square is equals to 50. That is what is given in the question, right? Now if you try to solve this particular part over here, you will get this as a equation of a plane. So from this particular part, you will get a equation of a plane, right? You can always try to do it over here, right? So if you try to simplify this part, you will get an equation of plane, right? You can always try to do it by yourself. So if you just do it, you'll get the equation of the plane as follows. So for set S, I'm solving for set S. So for set S, the condition is x comma y comma z such that this point is basically lying on 6x plus of 8z is equals to 105. That is the condition for the set S, right? So this is basic set S basically denotes all the points which is lying on this particular plane that is satisfying this equation, right? So set S denotes the point lying on this plane, this particular plane, right? Similarly, if you solve for set T, so set T will also come out as x comma y comma z such that it is lying on the plane, and the plane equation will be given as again 6x plus 8y is equal to 5, right? So you can find out that these two planes are having the same normals, the addition ratio of the normals, right? Which basically means that they are parallel planes, basically means they are parallel planes, right? They're differing, but they are parallel planes, right? So both S and T are the set of planes, right? Now it is said that there is a triangle whose area is 1 and all of its vertices are basically from S. Yes, it can be always possible that there exists a triangle whose area is 1 and whose all the vertices are from the plane S, right? So therefore this is correct option. Therefore this is the correct answer, right? Similarly, if you look at the second part of the problem, it is saying that there are two distinct points L and M in the plane T very sorry, such that such that each point on the line segment LM is also in T, right? So it is always possible that if I have two distinct point L and M on the plane T, hence the line segment joining the point will also be on the plane T itself, right? This is very correct. So this is also a correct option, right? Just very simple correct options are given, right? As you can see in the options. Similarly, there may be infinitely many rectangles of perimeter 48 two of whose vertices are from S and two of whose vertices are from T. So that is basically interesting part to check. So if we have the first plane, let us try to find the so if we have two planes and since which planes are parallel, let us try to find the distance between the two planes, right? The distance between two planes will be simply given out as 105 minus 5 divided by square root of 6 square plus 8 square, right? And that will give me the answer as 10. That will give me the answer as 100 by this is going to be equal to 10, right? So 100 by 10 is going to be equal to 10. So therefore, the distance between the two parallel planes is going to be 10. Right. Now, if I choose any two points over here, let us say P and Q, and let us say this is R and S, right? Or S dash. So therefore, I can always form a rectangle whose perimeter will be basically like from here the distance is basically 10 and 10, 20, and this can be kept as 14 and 14, and in that way you can always have infinite number of so in that way you can always have a rectangle of perimeter 48, right? Of perimeter 48, right? So therefore if you look at this particular problem, so therefore if you look at this particular problem, there can be a case for which this particular perimeter of a rectangle will exist, right? So since if the distance between two parallel planes is simply given as uh, 10 and 10, so 10 and 10 will be 20, so this is going to be 12. Okay, sorry, this is going to be 12, otherwise you're not going to get 48, right? So this is going to be, oh, am I doing it correct? No, this is going to be 40, 40 no, 48, right? So that means this is going to be equal to 14 only. Yeah, correct. This is going to be equal to 14, and the distance between the planes we have it is 10, right? So this will make up the total perimeter of the triangle or the rectangle is basically equal to 48, right? So there can be infinite number of solution because you can take the plane like this way. You can always make the rectangle like this way. You can always make the rectangle like this way, right? So there can be infinite many possible choices for this particular rectangles, which will have the perimeter as 48. So therefore this is also correct. This is also very correct because whose two vertices are from S and two vertices from T. So this is also basically correct, right? Now, if I look at this particular statement that there is a square of perimeter 48 whose two vertices are from S and two other vertices from T. Now, this is basically going to be critical. If it is a square, if it is a square, then I must have all the sides of the square to be same. But since our distance into parallel lines is basically equal to 10, I cannot have a square whose all the sides are equal to 10. In that case, I will have the perimeter as equal to 40, not 48, right? So therefore, this is not the correct answer over here. This is not going to be the correct solution. I hope this particular part is clear to all of you, right? Please let me know this part is clear or not. So I hope this thing is clear because it's a very simple idea. Once you are able to get the question very straightforward, right? So you solve the question step by step, you get the solution very easily. I hope this is making sense to all of you. Is this clear to all of you? Right? Is this part clear to all of you? So please go through this problem again. It's a very simple idea. They have defined the idea of the distance formula in form of a plane, right? So they are asking the question indirectly in a plane. So they are not giving you the plane equation. Instead, they are asking you to derive the equation of plane from the distance formula, right? From the distance formula, they are asking to derive the expression of the plane. So once you get the expression of the plane, from there to easily solve for the given options, right? I hope this is clear to all of you. I hope this is clear and simple to all of you, right? All right, so this part is clear. So let's move to the next problem then. Let's move to the next problem. So the next problem is another very interesting problem. The particular equation of a we have a particular equation of a plane, and it is said that S be the reflection of a point Q with respect to a plane, which is given as follows, right? So over here, if you look at the problem, the way of defining the plane is very in a vector format, right? So we have to define the plane equation in the Cartesian coordinate. That is also very possible, right? So there are two parameters while they are defining the equation of plane. There are two parameters, right? It is said that the parameters are T and P, and it is also said that if the position vector of point Q and S are given as follows, then which of the following options is or are correct, right? So they are asking for a given condition. Based on that, we have to check for which of the following options are correct, right? So let us try to first of all go through the equation of the plane over here, right? So if we look at the equation of plane over here, so the given equation of plane, I can always write it, or I can always rearrange it. I can always rearrange it and write it as, so r vector can be given as, so I am taking all the constant part to one side, right? So I can take the constant parts and let us write this expression as k plus, so just let me check. So first and foremost thing, what we are going to do over here is that let us take the constant part outside, that is k vector plus, and if you look at the t vector, t over here, so t, if I take t as common, then that is going to make me, so if I take t as common, that is going to make me minus I cap plus j cap, right? And if I take p as common, so if I take p as common, in that case, I'll get k cap, sorry, minus I cap plus k cap, right? I will get this as follows, right? So once I have the equation of the plane written in this particular format, now I always know that if I have two points or two coordinates whose points I know, and then the equation of the plane in parametric form can be always given out as, so equation of plane in parametric form can always be given out as a vector plus lambda times of b vector plus some mu times of c vector. I hope you know this particular parametric formation of the equation of plane. So that is what is mentioned in the problem over here. So that is how it is given in the problem over here. Now I would request all of you to please study the chapter very nicely, otherwise these questions, these types of questions are going to be very, very difficult for you to solve. Okay, so if you know the concept, then it is very simple, right? Otherwise it is going to be very, very difficult, because if you look at this problem over here, right, so it is said that if you have any point A and two other points B and C whose position vectors are given rather than the vectors itself, so then it is basically given like this way. Okay, so therefore the equation of the equation of the plane in the standard form, is generally from here. If we try to get the equation of the plane in the standard form, I can simply do that by, so that is basically, I can do that simply by r minus k cap and then minus I cap plus of j cap, and then it is minus I cap plus of k cap, and then if I take the scalar tail product to equal to 0, because I have three vectors, right? Because I have three vectors, and if I equate these three vectors which are lying on the plane and equate them to 0, then it is basically going to give me the standard equation of the plane, right? And if I try to solve this particular part over here, considering this r as, so r vector we are considering as x comma y comma z, right? So this is going to be x y and z minus 1, and this is going to be minus 1 1 0, this is going to be minus 1 0 and 1, and if I take the determinant of it and equate it to 0 for getting the scalar tailor product value, and from this we'll get the equation of the plane, and that will simply come out as x plus y plus z is equals to 1. So very simple way I am going to derive this particular following over here, right? So once you know the concept regarding how to write the parametric form of the given equation of plane, such that they are not giving you two vectors, rather they are giving you the coordinates on the lying on this particular, or the position vector that are lying on this particular plane, right? So from there also you can always solve for the given equation of the plane. I hope this particular step is clear, right? Now it is said that point q, now it is said that point q is given as 10 comma 15 comma 20, and point s is given as alpha comma beta comma gamma. Point s is given as alpha comma beta comma gamma, right? Alpha comma beta comma gamma, right? Now it is said that S is a reflection of point Q with respect to the plane. Now we have the equation of the plane, and once we have this particular thing, we can always try to apply the image formula, right? So if you try to apply the image formula, the alpha minus 10 divided by 1 is equals to beta minus 15 divided by 1 is equals to gamma minus 20 divided by 1 is equal to minus 2 times of, now we have to put alpha, sorry, we have to put the values of the point q into the equation of plane, and from that we'll get 10 plus 15 plus of 20 minus of 1 whole divided by a square plus b square plus c square, that is going to be equal to 3, right? So once we solve this, we are going to get this value as, so we are going to get the value of alpha minus 10, and this part is going to come out as minus 88 by 3. So alpha is going to come out as minus 58 by 3. Similarly, if you solve for beta, so beta is going to come out as minus of 43 by 3, and gamma is going to come out as minus of 28 by 3. I hope this part is clear. So once we get the values of alpha, beta and gamma, we can always solve for the options. So the first option is basically saying that 3 times of alpha plus beta is equal to how much? So this is basically equal to 101. Let's check with option. Yes, this is correct. So the first option is correct. Similarly, if you calculate beta plus gamma and multiply with 3, this is also going to be equal to minus of 71. That is also correct. Similarly, this option is also going to be correct answer. This also option is going to be correct answer. And if you look at the last option over here, this is going to be equal to minus of 120, 129, minus of 129. Therefore, this is not going to be the correct answer. So the correct answer to this particular problem is going to be option number A, B, and C. All these three options are going to be the correct answers. I hope this part is clear to all of you. Please let me know. Please do let me know if this part is clear or not. Right? Is this part clear to all of you? Is this part making sense? How did I derive the equation of the plane? Is this part making sense to all of you? It's very simple. I just use a simple concept of the scalar tailor product, right? I hope this is clear. Please let me know if you have any, still have any questions. All right. So this part is very straightforward. Once you are able to get the parts, right? Once you are able to get the idea of how to derive the equation of the plane, the question is very, very simple onwards, right? So I hope this question is making sense to all of you. And if you have no doubts, we can proceed to the next problem. Please let me know if you have any questions. Okay, so let's proceed with the next problem over here then. Now again, it's a question of finding out the mirror image, right? So it is said that alpha square plus beta square plus gamma square is not equal to 1, and the value of alpha plus gamma is equals to 1, and the value of alpha plus gamma is equal to 1, and there is a point 3 comma 2 comma minus 1, which is a mirror image, of a point 1 comma 0 comma minus of 1 about the plane which is given as alpha x plus beta y, plus gamma z is equals to delta, right? So this is basically the given equation of the plane, and it is said that this is the mirror image, right? So the very interesting way to solve this question is basically, let us first of all find the midpoint, right? Let us say this point A, and this is point A, and this is point B, and let us try to find the midpoint, right? So the midpoint will be simply given out by the midpoint formula, that is 2 comma, 1 comma minus of 1, right? That is going to be the midpoint. Very simple, right? Now since this is a midpoint, so the midpoint of the point and the mirror point, okay, or the image point, will always lie on the plane equation. So therefore let us try to satisfy into this plane equation over here. So if we try to do that, we'll followingly get that relation as 2 times of alpha plus of beta minus gamma is equals to delta, over here, right? So that is, let us equate that as one equation. Now similarly, the direction ratio, or if I try to find the vector of the direction ratio of the vector along the AB line, is definitely going to be the direction ratio of the same or parallel to the direction ratio of the normal, right? So let us try to find that direction ratio of this AB line. So dr stands for direction ratio for this AB line, will simply given out as 2 comma 2 comma 2 comma minus is going to be 0, right? Minus 1 minus of minus 1, that is going to be plus of 1, that is going to be 0, right? So this is going to be the position vectors, okay, or the direction ratios, right? So I can easily find the direction ratio by subtracting, right? So the vector AB will simply given out as 3 minus 1 I cap plus 2 minus 0 j cap, then plus minus 1 minus of minus 1, that is going to be 0, so 0 k cap, right? So that is what I've written over here, and this is basically similar and or parallel to the direction ratio of this alpha, beta and gamma. So therefore it is parallel, then alpha by 2 is equals to beta by 2 is equals to gamma by 0, right? Since they are parallel to each other, right? So from there, and I can always equate that to some particular constant, right? So that, let us say the constant is p, right? Now we have to also apply the image formula. So if I apply the image formula also, in that case also I will get the relation as very straightforward, that is going to be 3 minus, 1 by alpha is equals to, and the second part is going to be equal to 2 by beta is equals to 0 by gamma is equals to minus 2 times of, now let us put this value in this equation, that is going to be alpha minus gamma divided by alpha square plus gamma square plus delta square, right? That is what we have it over here, right? So I'm writing it very small. I hope you can understand, right? And so if I apply all these particular relations, and let us try to find out the given correlation from here. So once we apply this particular relation from here, now the very straightforward thing is basically I get the gamma is equal to 0. I get the value of gamma is equal to 0, right? I get the value of gamma is equal to 0. So if I gamma is equal to 0, then alpha will be equal to 1. And that basically means that point P is going to be equal to 1. So that will also give you beta as also equal to 1, right? That will also give you beta as also equal to 1. So once very simply, if we try to understand this particular ratio over here, then the part is very simple. So once we get the value of alpha, beta and gamma, then we can always try to look for the next part, right? Then it is said that then we also have one more relation, that is delta, right? So therefore from here our delta is going to be equal to, so our delta is going to be equal to 3, right? So alpha is 1 and beta is 1, so that is going to be equal to 3. So once we have all these following relations, then we can always solve for the given option. So if you look at the option over here, you will see that alpha plus beta is equal to 2, delta minus gamma is equal to 3, and delta plus beta is equal to 4. These all three options are going to be the correct option, and similarly the last option is not going to be the correct, right? The last option is basically 1 plus 1 is equal to 3. That is not correct, right? So all the three options, that is A, B, C, are going to be the correct answer. I hope this is clear to all of you. So if you do this correctly, you are definitely bound to get the following result, and therefore you're going to get the full marks over here. I hope this is clear and making sense to all of you. I hope this part is clear and making sense to all of you. Do let me know if you have any questions. Very straightforward. I just solved it very simple way. Right? Once we apply the concepts, the problem is very, very simple. Okay. It's a very straightforward problem. Very, very simple and easy. I hope this is clear to all of you. I hope this is clear to all of you. Do let me know if you have any questions in the live chat. Is this part clear to all of you? Right. If you still have any questions, you can always put that in the comment section. Okay. And if you like my sessions, please don't forget to hit the like button. And if you want to get your personalized doubt clearance or one-to-one sessions for especially for the upcoming JEE advanced examination, you can always contact my team with the given undersigned number. Right. So you can always find the contact details of my team and my contact details in the description box. Okay. So please contact my team if you want to get personalized one-to-one doubt clearance or you want to get personalized mentorship sessions. Okay. So I hope this is clear to all of you. I hope this is clear to all of you. Right? Is this part clear? Okay, wonderful. So once this part is clear, let's move to the next problem. So next problem is another very interesting and simple problem, and I have taken this problem from the integer based or numerical type questions. Okay. So if you look at the problem, there are three particular lines. We have the equation of three lines. All of these three lines, if you interestingly find it out, that they are all of these three lines are passing to this origin. Right? And it is said this all the three lines are intersecting the plane, are intersecting a plane at different points ABC, at different point ABC on this plane. And once we get this point ABC, we have to basically find the area of this triangle, the area of this triangle ABC. We have to find the area of triangle ABC, and that is basically given as delta. And then ultimately we have to find for 6 times of delta square. Right. So it is a very straightforward problem. So if you know how to solve this, it's a very simple problem. So the first equation of the line is given as x by 1 is equal to y by 0 is equal to z by 0. Right. I hope you can formulate the equation of the lines from here. Let us call this line 1. Similarly, if you to solve for line 2, it is x by 1 equals to y by 1 equals to z by 0. And similarly, if you write the equation for line 3, if you write the equation for line 3, then it is going to be x by 1 is equal to y by 1 is equal to z by 1, right? So once we have all these three lines, we can always try to find the point A, B, and C. Let us try to find the point A. So if you try to find the point A over here, and let us try to equate this particular thing as some lambda, and then solve with the equation of the plane, right? So if you just put the lambda, it is going to be lambda comma 0 comma 0, and from there you will get the value of lambda as 1. So point A is 1 comma 0 comma 0. Similarly, point B is going to be 1 by 2 comma 1 by 2 comma 0, and similarly point C is going to be 1 by 3 comma 1 by 3 comma 1 by 3, right? So once we have all these 3 points, we can easily solve for the area of the triangle over here. So the area of the triangle, we can simply do it by taking a cross product. So once we get the vector AB, and let us also find the vector AC, and let us do the cross product of here. Okay. So the area of the triangle, that is delta, is basically half times of mod of AB vector cross BC vector, right? So if you just do this calculation, you are going to get the value of delta. So once we get the value of delta, you can always solve for the given equation or the given solution for 6 times of delta square. Sorry, 6 delta whole square, right? 6 delta whole square, that is what you have to solve for. So please try to solve this question and let me know the answer you are getting. Try to solve for this question. And please let me know the answer you are getting in the live chat. It's a very straightforward problem. It's a very, very straightforward, right? Okay. So once you solve this and perform this cross product, you're going to get the solution over here. I know how you can do this cross product. Okay. Because you have to do the cross product by simply doing the determinant, right? So this A vector is going to be equal to, so if you look at the A vector, it is going to be equal to minus of 1 I cap plus of half j cap, right? And similarly AC vector is going to be like minus of 2 by 3 I cap plus 1 by 3 j cap plus 1 by 3 k cap, right? And then you have to do the cross product of these two vectors AB and BC, sorry, AC. And once you do the cross product and then take the half of it, and ultimately don't forget to take the mod of the answer, because ultimately we are interested into getting the magnitude of the area. right? So once you do that, you will get the value of delta, and from delta, you'll get the value of 6 delta whole square. So please let me know the answer you're getting. Please let me know the answer you're getting. What is the answer are you getting from here? Okay. So the answer that I have got by solution is basically is something as 3 by 4. If you solve for delta, the delta will come out as, if you solve for delta, if you solve for delta, the delta will come out as 1 upon 4 square root of 3, 1 upon 4 root 3, 1 upon 4 root 3. Okay, that will come out as delta. And then if you perform this 6 delta whole square of it, it is going to come out as 3 by 4. So ultimately, the numerical answer that is you're going to refer is basically 0.75. The numerical answer that you have to mark is 0.75. I hope this is clear to all of you. I hope this part is clear to all of you. Right. So if this part is clear, I think then this will actually build up your important base, especially if you're looking for the JEE Advanced. Okay. And this 3D geometry, the vector algebra, these are very, very simple chapter. Especially if you're looking at JEE Advanced, this chapter is very, very easy and they have really high weightage. So definitely look forward for solving the questions from this particular chapters. And please make sure that you finish all the previous year questions from these two chapters and get ready for the upcoming JEE Advanced examination. So I congratulate all of you who have already qualified the JEE Mains, and if you not, don't be upset. Again, you can always look out for the other options as well, right? So with this part, let's end our session over here, and I wish you all the best. So we are also going to have some more upcoming sessions on JEE Advanced, especially targeting for the revision. Okay, and looking at the JEE Advanced examination that is going to be in the month of May, right? So I hope you all know the dates, right? So therefore, for this particular preparation, we are also going to come out very strong in a very strong manner. We are also going to do some more revisions, and for each and every two concepts, we are also going to look at the previous year questions. So with this, I end my session over here, and I thank you. Thank you all of you for your giving attention for this particular session, and all the best for the upcoming examination. Thank you.